Okay, so we can start with Docker Run VLS. So basically, this will be a hands-on workshop kind of. So if you have your laptops, you can take them out and follow along. Okay, so we'll spin up your Lightning nodes along with VLS running in a separate container. So that's the plan for this talk. Yeah. Okay, so just a quick introduction. I'm Lakshya Singh. You can ignore the first line. I'm an open source contributor at Validating Lightning Signer, and I travel a lot, talk a lot, and codes a lot. Yeah. Okay, so this is the table of contents. Okay, so when we talk about node with Lightning, so this is what it typically looks like. Can I have the pointer? What's Thanks. Okay. So the basic part is the Bitcoin node. So the Bitcoin node is there. Then the Lightning node, which runs on top of it, connects to it through RPC communication. Then there's a UTXO, which keeps the unspent transaction output sets so that the Lightning node can connect to it and get this information out. And finally, there's a signer that sits on top of everything, which the Lightning node connects to and fro to sign the transactions. There is a Lightning storage server as well, which keeps the state of both the nodes, the signer and the signer in it, so that whenever you need recovery to happen, you can connect to the storage server and get the recovery information out from it. So these are the 5 basic parts of what will look like a good Lightning system: the Bitcoin node, the Lightning, the UTXO, the validating Lightning signer, and the Lightning storage server. So the old way generally, when you set up your Lightning node, is to download the binary. So you download the Bitcoin core, then you download the Lightning core Lightning code base. Then you have to install all the nodes on your system, download the build dependencies, and then compile the code and then start running it. So sometimes people generally would prefer things like Phoenix or Breeze to run this for them, because it's a lot of operations when you have to compile the code yourselves. So this saves, so what we are planning to do is save you the manual labor of doing all this and just do a simple command that will run it up for all for you. So as I said, at a high level, you download the Git repo or the tarball, you install the build dependencies, you build the binaries, and then you start the daemon services. So we hate exercise, right? We don't like to do exercise as well. So what will make it easier? So you just need to have Docker installed on your systems. So yeah, let's do that. Okay. So Docker can be installed. So generally on Linux, you download the Docker engine. On Mac OS and Windows, you can use Docker desktop to run things. So is there someone following along over here? I will just keep that in mind. No? Okay. Demo like that. Oh, right. Is it? Okay. Okay. Anyhow, I will do the demo for everyone then in that case. Okay. So the first part is downloading the VLS containers repo. So this contains all the Docker images for all the services and the Docker compose file to just start the system up. Okay, so let me just pull in my terminal over there. Okay. Wait, I will just duplicate my screen just a second. Okay. So let's go to the VLS containers repo. Okay. So I'm in the VLS containers repo now. So the repo, it consists of all the packages. So there is the TXO, the VLS daemon, the Lightning daemon, the Bitcoin daemon, and the compose file for the network. So there is the basic compose file, there's the testnet, and the registrar file. So these are the two networks that we are supporting as of now, because we are in the testing phase right now. So okay. So what we can do is, it's as simple as, just a second, I'm not able to see the screen. Okay, so what I will do is, so so running a Docker node, so running the whole system becomes as simple as running this command. So you can see it's spinning up. So the Bitcoin node is up, the VLS node is up, which is waiting to connect to the Lightning node, which comes up after the Bitcoin node is up. So it will, so I will show you now one more thing. So we can see that there are health checks in place to ensure that the nodes are up and running. So if I check, we can see that the VLS node is healthy, but the Bitcoin D is still starting up. So the health checks are not done yet. So that's why, so the Lightning D and the TXO wait till the Bitcoin node spins up properly. So let's see, the health checks are still starting. Okay, it's rolling forward. So this might take some time, I guess. Yeah. So Bitcoin node is unhealthy. Okay. So let's do something else. Profile stop. Okay, so instead what I will do is connect to the cloud node that I have set up beforehand, because I knew something like this can happen. So let's do that instead. Okay, so here I can see everything running up. So the Lightning node is up and running, it's healthy. The TXO is restarting because it's still trying to catch up on the reorg, and the Bitcoin D and Lightning network are healthy. So what we can do with this setup is, so let's say I want to check what block I am on. So it's it becomes as easy as initiating something like, so the Bitcoin CLI is installed inside the Bitcoin container. Similarly, the Lightning container has Lightning CLI, VLS container has VLS CLI to interact with the system. So I can do blockchain info. So now I can see what block I'm on. Similarly, I can check with Lightning's network what is working there. Testnet and summary. So I can see all the nodes, all the channels that I have connected and running. So okay, so this is the part. So basically you download the repo and then you just build the Docker images with this single command, and it will spin up all the services for you in the next. So during the build it can take some time, because Docker images need to pull in the binaries and start compiling the system. So one thing is, you can take the time out to see the process happen, or if you don't have as much patience, so you can just so with Docker it's a bit off that they sometimes cache things properly, sometimes they don't. So if you create a new builder, export these variables. So we are basically using the cache that is there in our repositories, and then use the scripts. So this will pull in the cache from the repositories and then build the images at a much faster pace, because it doesn't have to wait for the compilation. If your files are unchanged, it will just pull in the cache and get everything up for you. So I had this in place in case you wanted to build it at a faster pace and not wait 10 minutes for it to compile everything. You can do with this. Now every node, every container has its own persistence. So Bitcoin blocks and headers are stored in Bitcoin data. Lightning details are stored in Lightning data. The UTXO stores all the attestations in TXO data, and VLS stores in data with the private keys in the VLS data volume. So each has separate volumes which nobody else can interact with. And the starting up service, as I said, it looks like just this command. That's it. So this gets your node up and running. So now one thing is uh, the base configuration, it doesn't expose your node to the host machine. So when you're working with Docker, it's an isolated network. So when you want to connect with other nodes, you want to expose yourself on the network. So that can be done if you use override. So in Docker, you set in the base compose file, then you provide in the override for the network that you are running, and then you start the node. So this override will expose your node to the host machine. So the ports will be open now for other nodes to interact with you. So right now we support two overrides, that is testnet and regtest. Now what we want is for VLS to run on a security hardened device. So things like STM32 signer, or let's say something like Amazon Nitro or Azure. There is confidential compute VMs. So those are the places where we'd want VLS to run. So that is a secure environment for your keys to be. So to run VLS separately from the Lightning whole system, what you can do is you can use the Docker image, that is just the VLS Docker image, and you can export the required environment variables, provided the bitcoind RPC URL, the CLN remote HSMD URL, and then spin up the VLS node. So the VLS node will be running in a separate thing apart from all the bitcoind, Lightning, and TXO. So that keeps the system secure. Now changing version, so everything updates really fast. So what we have set up in this repo is, so there is, let me show it to you. Okay. So in VLS container, so you can see there is a .n file over here. Is it? Yeah, okay, it's hidden. Yeah, so there is a .n file. If you check the .n file, so basically it has git hashes. So the Bitcoin version is 26, and this is the SHA-26 sum of the Bitcoin tarball that we download. Then for the CLN repo, again the repo URL and the git hash that we want to check out to. Similarly for CLBoss, which is used for creating channels and doing operations for you automatically. Then there is CLN plugins, the TXO repo, and its git hash. So anytime you want to change the version, what you have to do is just update the git hash to wherever you want to check out and build the images again, and it would be all good. So you will have a new version established, and it would be as easy as changing the git hash in this file, nowhere else. So you just update the git hash or set in a tag, and then build the images, pull your system down, and then start it up again. So the current versions are, so we use the default versions that we have set in the repo as of now, which will get updated over time. So Bitcoin Core is running in version 26. Core Lightning is using 24.02.2. TXO is running on version 0.6.4, and VLS uses 0.11.0. So in the Docker images, we utilize multi-stage build. So if I show you how much does a single Docker image, what is the size of a single Docker image? So let me just pull it. Okay. Yeah. So let's check the VLSD. So this is just 300 megabytes, and the largest part of it is the dependencies that are there. So this is just it. We don't keep in build dependencies. We just keep the relevant binaries and the runtime dependencies required. So that is what makes the final Docker image very lean. And if you check the bitcoind, I checked in last time, it was just a few megabytes. So if I check bitcoind, this is, again, I think it's around 50 megabytes. So that's all it has. Okay. Yeah, so we use multi-stage build to ensure that the final Docker image that you get, it's as lean as possible. We use the Alpine base because that is the leanest Docker image available right now. So the final output is very lean. So Docker has two versions, that is Docker Compose version 1 and Docker Compose version 2. So there were a few breaking changes in version 2. So given that current Linux distribution, be it Ubuntu, Manjaro, or any other else, the by default versions that you get when downloading from their repositories is version 1. So we wanted to support both the versions, so that version support is there. Now the health check. So as I showed that if one of your containers is down, it's as easy as looking up doing a docker ps and checking which of the containers is down, and then you can see if it's healthy or not. So there are health checks in place for all the 4 services. bitcoind has a health check, vls, lightning, and the TXO, all 4 of them has health checks. The other security thing that we ensured was non-root. So none of the, except TXO, which we are planning to shift, all the 3 services run in their own user space. So none of them has root access when they are running the process daemon. So Bitcoin has Bitcoin user, Lightning uses Lightning user, and in VLS, if you see over here, yeah, we create in a new group VLS, and that is what a VLS uses while running. So none of them run in root space. Then the persistent part comes from the Docker volumes that are set up. So even if your containers go down, your Docker volumes are there to ensure that you can just start the containers up again and things will start running again. So now to interact with the containers, there's simple command. So you can use docker ps to check on the status of your containers. To get the logs out of container, you can again use docker logs. If a service goes down, you can just do a docker restart to start the container up again, which quite frequently happens with lightning nodes. They go down and it's intermittent error. So if you just restart it, it comes back up again. And if you want to delete all the services and restart, you can do a force recreate. So that will pull down the services and create the containers with the new image that you have built. And in case you want to delete a docker volume, you can do docker volume rm, the volume name, and then recreate the volume and start the service up again. So these are the few commands. Basically, all the services have their own CLI, which can be used to execute this. So let's do this one. Let's say this will get me a new gossip here on the cloud node. Okay, so yeah, so now if I check docker exec lightning d - test lightning CLI - testnet summary. So I can see the number of gossipers is 4, and if it was executed earlier, the number of gossipers was 3. So you can execute all your commands using this. It doesn't stop you from doing anything that you can by manually setting them up, or using the docker containers. You can do everything that's possible. And then you can create new addresses to receive funding, so things like that. And yeah, that was basically the docker thing for you. Now one thing that so some hackathon ideas that came up to me was, so given testnet recently had a major reorg, so my node went down like 2 days back, and I was like, I won't be able to do demo now because testnet reorgs, it was too deep, and so VLS didn't allow it because of the security feature. So I would want, if possible, to run the docker set, allow running docker setup on something like Signet or Mutinet. And one thing that has been pending is the integration of LSS for easy recovery with the Docker system. So that is the plan that we have going forward, that with the 4 services, along with that in the Docker setup, we want to include Lightning storage servers so that the recovery can happen quickly, even if, let's say, your node goes down or they get out of sync. So these might be 2 things that I want to see happen in the near future for Docker. Yeah. No, that is generated in the Lightning node. VLS just gets a hold of it when it starts up. No. The Lightning node creates the key, but VLS gets a hold of it as soon as it starts up using the HSMD connection. So the Lightning node doesn't hold the keys anymore. The VLS is the one keeping the keys for you. Hmm. No, so the private key is in your Docker volume. So the persistence, yeah, the persistence is always there, which ensures even if the container goes down, you can just bring it back up again. So this has been ensured. Yeah. Okay. Um, yeah, I think that was all I had in mind. So this was all for VLS on Docker. Yeah. Thank you. No, we initially thought that we should push the images, but just for the security purposes, we'd want you to build it on your own. Yeah. Maybe they will inject some binaries on the Docker Hub because recently I think there was a security scenario on Docker Hub. They had like 3 million or so images which were doing nothing. So yeah, it's in the main repo. You can just build from there. Yeah.